Okay, in the past week, we have spent a fair amount of time working on this idea of generalizing a pattern. Now, if you don't know this word, generalize, don't stress out. I'm going to kind of walk you through it. So for each of these, and I picked out stuff that we did kind of early last week and late last week. This, on this side, we started looking at various figures and kind of seeing how they grow. And the first thing that you really need to do is you need to notice a pattern. And what I mean by that is you really need to start seeing what's happening within this pattern. What kind of things can I see there? Now on this one, you might notice that there are kind of two little squares that always exist in every piece of it. You can always kind of count on these next ones being there, and that is just something that I'm always going to see. Then you might start noticing, well, I noticed that if this is 1, this is 3. If this is 2, this is 4. If this is 3, this is 5. Every single time it looks like that this length, where we're going like left to right, that this is 2 longer than it is tall. That's really what you're noticing. I'm just looking and seeing what kind of things exist in this pattern. And the next thing that you're going to do is you're going to start to describe this pattern. And as you're describing it, really what you're going to do is maybe start noticing some numbers. So you might notice that in this first one here, there are 5 squares. In the second one, there are 10. In the next one, there are 17. And we can really start describing what the next figure would look like. So the next figure, I think, what we'd start looking at is we would say, okay, it would definitely have those 2 kind of pink ones. And we know that however long or however tall it is this way, it's going to be 2 bigger this way. And since this was 1 tall, 2 tall, 3 tall, so like right here, 1, 2, 3, I can put a fair amount of confidence in the fact that this next one is going to be 4 units this way. Here we have 3, 4, 5. I feel pretty confident saying this is going to be like 6 units this way. And so this is me kind of describing and extending the pattern. And so in this case, I would have 4 times 6 is 24 inside this purple rectangle, plus these 2, 24 plus 2, that would get me a total of 26 for my fourth one. Now, as I move from describing to generalizing, what I really need to do is I need to start seeing things that are always true. For example, if we call this figure 1, this is figure 2, this is figure 3, this is figure 4. When we say generalize, what we're talking about is like, I want to be able to go all the way out to pick some big number, figure 53. What is figure 53 going to look like? Well, I'm going to need to do a little bit more than just describing like this like tall side here went up by 1, and this side right here is going to be bigger than 2. I need to figure out like, because I don't want to draw figure 5, 6, 7, 8, 9 all the way up to 53. That's just too much. So as I move from describing it to generalizing it, I need to start thinking about ways that I could kind of skip some of those steps, and maybe how I could go directly from the figure number to here. Now, I know it doesn't matter where I go, I'm always going to have those kind of 2 squares sitting at the top and bottom here. I also might notice here that like figure 1, this matches, that's 1. Figure 2, 1, 2. Figure 3, 1, 2, 3. Hey, okay, could I just then say, sorry, I should probably use my purple here, that this is going to have to match and be 53 long. I mean, that seems to match with all of them. Okay, cool. And then since I noticed over here that this is 1 and this is plus 2, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. Here, 53 plus 2, this side is going to be 55 units long. Even now, I haven't quite generalized yet, because really what a general version would be is what would figure what will figure x look like? And by x, I just mean any number whatsoever. And really, I'm almost there. I know there's going to be 2 here. I know this side is going to be x long, and I know this side is going to be x plus 2 long. So I know that in figure x, I will have x times x plus 2. That would be like my 4 times 6 is 24 on the inside here. And then I need to add my plus 2. This right here is a generalized expression. And that's really the goal, is that I can use something concrete to help me get to a general one. So now if I want to know figure 4,000, I could just plug in 4,000 for x, 4,000 plus 2 in the end, and I would know exactly how many there were. Now we did the same thing with this Mr. Meyer climbing the stairs, and what Mr. Meyer did was he went up 1 and down, up 2 and down, up 3 and down. And before he could go to the next stair, he had to figure out, like, okay, how many total stairs am I going to do? And what we noticed was that in the first one, he went up 1 and down 2. That was 2 steps. So let's start by going back, and we're going to start with noticing. So at first, Mr. Meyer goes up 1 and down. So that costs a total of 2 steps. To get to the stair 2, he has to go up 2 and down 2. So that adds a total of 4, which means that he has to go a total of 6 steps. So again, that would be like 1, 2, 3, 4, 5, 6. So now to get all the way up to the 1, 2, 3, 4, 5, 6, the third step, he's going to have to add. So here we added 4. Here we're going to add 6. That would get us to 12. To go up to the fourth step, 1, 2, 3, 4, 5, 6, 7, 8, he's going to have to add 8. And now you might say, well, hey, I see a pattern. 4, 6, 8. I bet I'm just going to have to add 10 to go to the next one. And then I'm going to have to add 12, etc., etc. But what if I don't want to figure out all of this in between, and I just want to skip all the way to 21? And that's how many steps you really had to do. Well, that's a little bit trickier because we've kind of noticed, now we're describing it when we're kind of creating this pattern, is I'm saying, okay, plus 4, plus 6, plus 8, plus 10, plus 12, I'm seeing that. But in order to generalize this, I need to start seeing, just like we did here, how 1 connected to 5 and 2 connected to 10. I need to start seeing this number connecting to this number connecting to this number. And I had a brilliant, wonderful student in one of my classes notice that this number right here is 1 times 2, and this is 2 times 3, and this is 3 times 4, 4 times 5, 5 times 6. And this way, notice they're starting to see 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Which means when we get down to here where we have 21, I should just be able to say this is 21 times 22. And thus, feel free to use a calculator at this point if you want, but you get 462 steps in this case. And then I didn't have to add 4, 6, 8, 10, 12, etc. Now I get that kind of seeing this connection that 3 is the same, or 12 is the same as 3 times 4, 4 times 5, 5 times 6 is a little bit of a leap, but we're going to talk about different ways we could get there. But we can now totally generalize here and say, no matter how many steps, what we can just say is it's going to be times x plus 1, whatever that ends up being. So if it's 50, we'd multiply 50 times 50 plus 1. That's kind of where we're going so that we can first notice what's happening, then start describing it, finding different ways to go directly from this number to that, and then we can finally generalize. that's kind of what we've been doing. When you get to the activity with the gardens, that is also going to be our goal. I'm going to make a separate video because this one's already 10 minutes long. Let me know if you have questions.